Hello, and welcome to the FSAE Power Senior Design 1 Expo. My name is Dawson Pauly, and I'm joined with Spencer Nichols, Jeffrey Cecil, Nate Brucialelli, Michael McCrary, and Arian Dubiansky.
For this project, we were tasked with developing an induction and exhaust system for a 2017 Husqvarna 701 LC4 engine. This design will be used in a Formula SAE application and therefore must comply with all FSAE rules. We are also tasked with developing a GT Power model to predict accurate performance results, as well as complete CFD simulations to validate our designs.
Our design process is to develop a 1D gas simulation using GT Power and previous FSAE engine designs. We'll validate the model by testing old engines and comparing experimental parameters with those found in GT Power. Once we have a proven model, we'll optimize our engines by adjusting runner lengths and plenum volume. We will then model our new design with SOLIDWORKS and ensure that it's compliant with FSAE rules.
Concerning the work we've already completed, we've developed a preliminary GT Power model to simulate the engine. We are validating our results by using the volumetric efficiency, and the output of that can be seen on this slide. To develop this model, we have done research and gathered all of the proper data, such as valve lift profiles, cylinder geometry, and other operating parameters of the engine. We're continuing to develop this model to match or to mock a volumetric efficiency curve that we deem accurate. On the left below, you see a volumetric efficiency that tails off and drops largely at high RPM, whereas on the right, you see it remain fairly stable throughout the power band.
Our completed work also includes a new engine stand, as the mounting points for the new engine is significantly different than the old engine. So we had to make a new stand to mount to another frame to get it to mate up with the dyno. We have also created solid models of our testing components so that we can double check and make sure that it's going to fit in the chassis, and so that we can modify the designs to optimize flow.
For our future plans, we plan on continuing to refine GT Power. We're going to test the engine on the dyno stand to validate the GT Power model. We want to use CFD to optimize the geometry and then re-verify with GT Power. And then we also want to use the flow bench to validate the CFD.
Thanks for listening to our presentation. If you have any questions, please contact our project lead, Spencer Nichols, using the contact information provided.